Good morning, or good afternoon, depending on where you are. Welcome to the digital session on the topic of mastering Databricks with Unravel Data. I'm Diana. I'm joined today by Unravel's Chris Santiago.
Hey, folks.
Before we start, some quick housekeeping. If you have any questions, feel free to pop them into the questions box, and we'll answer them live or by email reply if we end up with too many questions. This webinar is available instantly on demand, so if you do have to drop off, feel free to come back to this page and listen at your leisure. Let us know what you think about the session by rating this webinar, and also let us know if there are other topics that you'd like to hear about. So with that, I will give the mic to Chris.
Awesome. Thanks, Diana. Hey, folks. Again, my name is Chris Santiago. Just give me a second here to get my screen ready here. And so for those who don't know me, my name is Chris Santiago. I'm the global director of solutions engineering here at Unravel Data. I've been with the company for a little over 3 years now. And throughout my journey with Unravel Data, I've worked with many companies, more specifically, at least in the context of this discussion, folks that are looking at Databricks or are already customers of Databricks and are looking for best practices. I've worked with companies with large DBU commits. So like the folks that are trying to scale this out, at a large scale, all the way down to folks that are just starting off their cloud journey, Spark specifically with Databricks, and maybe just starting off with a pay-as-you-go model. What I'd like to do is share some of what I've seen, some best practices of what works, what to avoid, so that way you get the most out of your investment. And I hope that when you walk away from this talk today, that you have a good understanding of what it takes to master your Databricks environment. All right, without further ado, so the topics I'm going to cover today is, in order to become a Databricks master, there are going to be a couple of things that you're going to want to be on the lookout for. And so for folks that are doing it right, they're making sure that they're ensuring their jobs are adequately resourced. They're looking at just the code quality itself, like, hey, are my SQL queries written in a correct format? Am I writing optimal code that's leveraging resources accurately? Reduction of mean time to resolution. So for folks that don't know MTTR, mean time to resolution is, so think of that as, hey, my job had failed, or it's a lot slower and maybe it's costing me more. How do I quickly troubleshoot and triage that, both from a job perspective, but then also just maybe multiple jobs, or maybe this is a scheduled job and it's a pipeline. And so folks that are doing it right are able to quickly reduce that mean time to resolution. And then finally, last but not least, how do I ensure overall return on investment, making sure that not necessarily reducing my DBU commit, but really just optimizing for accurate consumption of my DBUs in Databricks. So that way, and by doing that, by understanding how my users are using their DBUs today. And so we'll first start off by talking about, how do you ensure jobs are adequately resourced? And so usually when I work with customers, the first thing is I ask them questions and I try to get a gauge of where they're at on their journey. And, the first topic is, how are you making sure that you are, adequately resourced or sizing your jobs correctly? We'll first start off by, hey, are you even using the right cluster type? So for folks that are familiar with the Databricks model, there's a automated or an interactive style of cluster that's always on, or also considered an all-purpose compute, or you can have like a jobs cluster, and so really the difference between these use cases is that all-purpose is something that's always going to be running, versus job clusters where it's I've got something that's already scheduled. Or I have, maybe it's a productionalized code and I want to be able to schedule that. A lot of folks that I've seen, they may start off by using all-purpose compute because, hey, this is the world that I'm used to. Maybe I'm coming in from a Hadoop background. I'm used to having just a cluster that's always running. And a lot of folks may start off that way, or maybe there's real reasons to have interactive clusters, right? Maybe it's it's powering a BI dashboard, and you need this always running environment. The reason why you would want to understand that is if you look at, this is just an example. So this is AWS Databricks pricing. If we just focus our attention here on the standard model, you could see that there is a pretty significant price difference here. By the way, this is pay as you go. I'm sure for folks that have contracts with Databricks, this may not be what you're paying, but just to give you an idea, but that all-purpose compute cluster, which is, while it's great, there's a premium to that. So if there's ways of understanding which jobs might actually make sense to move into more of a jobs compute model, it behooves you to understand which ones make sense. So having a good understanding of that is going to make sure that your jobs are adequately resourced. Another thing to keep in mind is, hey, auto scale, right? So for folks that maybe new to the whole auto scaling concepts, it's really the ability for us to set like a minimum number of resources, a maximum number of resources. And really with the idea here is to, really just try to scale with the, with the type of data that you're crunching, right? And so, for maybe slower days, maybe a smaller number of clusters or worker nodes, for the heavier days, basically you rely on the Databricks API to figure out which number of nodes that you need. While this is a great way to make sure that you are ensuring that you're not overpaying for resources, there are some things to think about where it could be adverse, right? I've seen customers where they've set their auto scaling maybe too low, and so what happens is the job will start, and then it'll come up with the minimum number of resources, and then maybe midway through, maybe towards like the end of the job, then it needs to scale up. Normally that's not a big deal, but there is time for that to happen, right? And if you are doing a lot of jobs, you are paying for those resources while we wait for the clusters to scale up or scale down. And so you do want to be kind of like in the ballpark of what that minimum is, what that maximum is. And the only way to do that is if you have a clear understanding of, where, what should be the minimum, what should be the maximum, right? And so when used correctly, auto scaling can be very useful, and you can use it to your advantage. Last but not least, do you know if you're picking the right instance types? And so where this is coming from is when you're creating your clusters, whether they're interactive clusters, whether they're job clusters, you also have the ability to select the specific VMs, right? So is it going to be memory intensive? Is it going to be compute intensive, right? It's up to you to decide, what that makes sense for you, right? The challenge here is a lot of times it's up to the developer to select this. And so are they over allocating their resources? Are they asking for node types that, that are, really over allocated, and there's wasting resources, right? In the on-prem world, maybe it didn't make that much big of a deal because sunk costs, you've already paid for those resources. But in this pay-as-you-go model where you're actually paying for resources on demand, you're going to pay, a pretty penny if you're over allocating your jobs, especially if they're scheduled. And so you want to have some level of insight of understanding, hey, am I picking the right instance types based on the type of jobs that I'm submitting in my cluster? So those are things that if you have answers, great answers for these, then you are on your way to becoming a Databricks master. All right, on to the next topic. So ensuring optimal code quality. And so the first topic we were really centered around resources. This time, let's talk about the actual code. So think of like the SQL syntax, think of like your PySpark, your Scala code, whatever it may be. Again, I ask questions for folks, how do you have the right tooling to troubleshoot code issues, right? Do you have like a good line of sight of, what's causing bottlenecks, et cetera, and so forth? And so, so a lot of folks maybe they have the right tooling, but they don't know how to correlate this. Say, for example, like, you've got logs that are coming in from Spark. You've got the Databricks console. Are you correlating this the correct way to really understand why my job failed? Why is it running slow? So on and so forth, right? And so, do you have the proper tooling so you can quickly troubleshoot that? Do you have visibility into understanding code issues just in general, right? Where Spark history is great, and Spark, the Spark UI is really great for showing you performance, but how do you know if it's on a specific line of code, right? You can figure that out if you start correlating some of that stuff with the metrics with like the logs, but like, again, there's a level of expertise that's expected for you to kind of get that information, right? And so if you're starting, maybe you're a new junior developer, this can become a challenge. It's just trying to understand, where do I even start if I'm having some code quality issues? Last but not least, do you have the right experts on your team? And so I think this is pretty standard. I'll make an assumption here, but I'm a lot of customers that I work with, you've got a few outstanding, very experienced developers, but you have way more junior developers, right? And what ends up happening, at least the model that I see a lot, is that you've got a lot of the experts spending a lot of their time, troubleshooting and, helping out their team members with their code, when they could actually be spending their time on doing like high quality stuff, right? Maybe like writing the newest, algorithm that's going to, generate profits for your company. So there's challenges from that regards, and a lot of times maybe like the whole team is new, and so there's a lot of time that's wasted just trying to understand, like, how do I interpret all this detail, all this data that's coming in from Databricks, and how can I make sure that my jobs are optimal? And so, having the right experts on your team is great. And again, in the whole context of being a Databricks master, if you have good answers for all of these, then you're on the right track. All right, third one, reducing mean time to resolution for slow or failed jobs and or pipelines. So let's face it, even the best folks that are creating the best jobs, stuff happens, right? Things are going to fail. Things are going to run slower than what it was expected, right? Do you have the right, right tools to have the right visibility to identify where the jobs fail? Was it something on, maybe if I'm on Azure Databricks, maybe there was a network issue, do I have visibility into that? From a pipeline perspective, if one job failed, how did that affect, all the other jobs that are, that were scheduled? Do you have the right visibility to identify that just in general, right? And so that's something to think about. Do you have the expertise to understand the issues that arise? So again, coming back to that whole, do you have the right experts versus junior resources to understand, correlate all this information, and quickly identify where the slow or failed jobs are? And finally, are you able to understand trends in your data pipelines? So, over time, jobs are running. Depending on the type of data pipelines you're managing and monitoring, if the trends are like the data volumes are going up, well, then you need to change your code, right? Or if like the expectation is that your data pipelines are going to be running, the same amount of time, and then one day it ran like 5 hours longer, 3 hours longer, you're going to want to understand why did that happen, right? And so the only way to do that is to understand the trends of your overall data pipelines and then take action based on some of the anomalies that you may detect. And so again, mastering Databricks would be being able to answer and have a good answer for all of these questions. Last but not least, ensuring our return on investment by understanding usage trends. And so, we're not in the business of trying to reduce DBU consumption. In fact, we want to make sure that, you as a customer is optimizing, the resources that you're leveraging, so that way you can onboard more work use cases, more and ultimately be successful in what you're trying to do with Databricks. But the way to do that is you have to have a better overall kind of visibility into, hey, how are my users or workspaces, how are they consuming? How can I identify the top 5, the top 10 most jobs that are spinning up the most DBU spend, right? Maybe that was by design. Maybe it's something where we can actually, improve on, right? And so do you have a good handle of where, most of the consumption is consumed, either like on a user or on a workspace, or even like on a pipeline level? Are you even tracking costs at a job or pipeline level? Taking, for example, like Azure Cost Management Portal or like AWS Cloud Health, it can give you good insights on like how the services are consuming. But if you want to get even more deeper, maybe I want to track this on that user level, right? Or the job level, do you have the ability to do that? Why would that be useful? Because I want to identify where the biggest spend is, and identify where places where we can actually optimize this, so that way we can use those DBUs somewhere else on a different pipeline. Last but not least, do you have visibility in your DBU consumption over time? And so are you understanding kind of that whole trends? Are you understanding how trends, how our users are using their resources over the life of their particular job or pipeline? And what can we do to make sure that we're optimizing this for efficiency, but then also making sure that, hey, we can start onboarding more workloads because we're being very optimal with the workloads that we're supporting. So, what if there was a tool that could do all this and give you that visibility? And you guys are in luck, because there is a tool. The tool is called Unravel. And so with that, I'm going to go and break off into my demo here. And so we'll touch on those 4 components before that I had mentioned previously, and how we can augment the experience of maximizing your Databricks environments with an observability tool like Unravel. And so going back and revisiting that code quality aspect, Unravel has the ability to connect into your code and do various things, such as show you the code that you had submitted. We can look at various timings. So say, for example, I wanted to understand, where did most of my time was spent on this particular Spark run? Was it the input stages? Was it the processing stages? I had the ability to drill into, even more granular. So right now I selected the input stage because it looks like that's where most of my time was being spent. And where did all that go? Like, was it spent here? I can see a lot of it was CPU time, amongst others as well. We can look at things in terms of how much time was spent from garbage collection, scan time. If we want to get a better understanding from an IO standpoint, like, hey, how much time or how much disk was used for disk input versus, or time was spent for disk input versus, disk output, shuffle write, so on and so forth. I can get a level of visibility or observability from this standpoint. We also have some high-level things to point out. Here we can see that input stages that spent more than 50% of task time on CPU. So we can start getting, this is my code. I've submitted it. Where's all my time being spent? That's where I can get this like overall from the job level. I can even get down into the particular jobs itself. And so here I can see, one of my jobs in this particular Spark job took 14 minutes. So I can go ahead and drill into this guy. Say, for example, I'm really curious about like, where did most of my time get spent? So I was able to sort this by duration here on this column here. And if I drill into this particular stage, now I'm at that stage level. I know I'm getting into the weeds here a little bit, but for the folks that are very curious about optimizing their code, this is going to really help them. So now I'm in the particular stage. I can see where time was being spent on this particular stage. So it took 13 minutes. I can even get into like the timeline and get a nice visualization of, where did the time get spent on this particular job run. I can go and look at here. Let me actually go ahead and just refresh the screen. That's how you guys know that this is a live demo. So 1 second here. So, all right. Bear with me here, guys. Make sure that my, 1 sec. All right, if this doesn't load up, I'll wrap up. So the, in this, oh, there we go. And so in this particular view, we can overall see the code that I had submitted, whether it's a SQL query, whether it's a, Scala, PySpark application. Hold on 1 second here, guys. Okay, I may not need to move on to the next one here, but here we go. Let me see if I can pull this up real quickly. All right. What I did want to show here, and I'll have to talk it through, is we do have insights we do have an insights and an intelligence that's built into the tool itself, which can actually proactively show you, hey, here's some things that we can do to improve the application. So if I go ahead and click on this guy, and so here's, in this particular case, we could actually do some improvements on the auto broadcast join. And so here is the value that me as a developer had put in from a configuration standpoint. We could actually be more optimal and maybe perhaps increase the performance of this particular job if we had run this auto broadcast join threshold, or increased it in this perspective. And so, great tool from an observability standpoint of understanding, where some of the gaps are, where some of the time is being spent from within my code itself. But then we can also augment that with our insights and recommendations engine to give you some, proactive input of like, hey, this is something that you want to think about to actually improve the performance, or even, things that we can do from a code perspective. All right. Next example here. This is going to be talking about ensuring resource efficiency. And so we've gone through a couple of examples here. One of the things I wanted to show here is same look and feel in terms of like showing from an observability standpoint how the job had run. Here's an example where we're looking at the particular job itself, and when we're showing, in this particular case, I submitted this job with VM that was 256 gigs of memory, 64 cores, cost me $487 an hour. And hey, look, this is a grossly over allocated job, right? I could have done this with much less memory, 14 gigs instead of 256, and 4 cores instead of 64 cores. And throughout the life of this application, I could expect to save $17.86 just by changing the instance types alone. And so when we talk about improving for your instance types, this is what I'm talking about, right? Now, auto scaling, we had talked about before, very powerful feature, but auto scaling is going to auto scale this, guys. So if you're over allocating your instance types, are you really saving if you're just using auto scaling alone, right? So you want to get even deeper and understand on the code level in terms of like what the consumption is. Is there room for improvement? And in this particular case, there is. And here's a good example where Unravel's recommendations engine is able to process everything that was run in this particular environment, and then give you recommendations in terms of what instance types that you want to use. Another thing that we can do too, here's another example where auto scaling was set up. And so here you can see, this is a smaller environment, but I've seen this much larger in customer environments. But here's where you could see I started off with just 3 containers, and that was my minimum. And then there's some time, then I jump up to like 5 containers, right? Now, the time that's spent here is not too bad. It's 5 minutes and 6, about 3 minutes here between, going from 3 containers up to 5 containers. But while the job is auto scaling up into increasing the number of worker nodes here, there is some time wasted there, right? And you're still paying for those 3 resources here, right? While this other stuff spins up, right? So if you aggregate this up, if you're using poor settings for your auto scaling in terms of minimum and max, you're going to have a lot of wasted time with these resources, spinning up and down, right? And so it's better to understand that, hey, maybe I should start with 5 so I don't have to waste the time of these resources spinning up, right? And so, a lot of times we see this with a lot of scheduled jobs, and the more time that we can just be more accurate in terms of like what those auto scaling settings should be, obviously that's going to be, beneficial for your jobs, and ultimately making sure that you are optimizing your DBUs for things that you want to spend it on versus, waiting for these, resources to spin up. So from a resource efficiency standpoint, here's another great example of understanding, how auto scaling affects a particular job. Now let's go ahead and switch gears here. We'll talk about that mean time to resolution. And so I'm sure there's a lot of folks on the call here that submit jobs and maybe they fail. Not everybody's perfect, right? And so you want to understand, where did it fail, right? What could I have done? And with Unravel, we do bring in, various logs, right? Whether it's coming in from Databricks, whether it's coming in from Spark. And so I like to call this, we're grepping for errors, like in the logs. And so for folks that really, this is their best way of understanding what happened with their particular jobs. We do show things such as like the fatals, the errors, the warnings. And so now I can come in here and get a good understanding of like, okay, I see that I had an issue with garbage collection and my limit exceeded. And so I ran out of memory, right? So I can get that from the logs. I could also use Unravel's insights and recommendations engine to also give me some additional context, right? So I can see here, I not only did my driver fail without a memory, but then also my executors have failed as well. And so again, this is very good and useful for folks that if something had failed, how much time does it take for you to troubleshoot a job? Sometimes it could take minutes for folks that know what they're doing and know where to look. Sometimes it could take hours, or maybe they don't even understand it at all, right? And so having a tool like Unravel, think of it as like an expert, a Databricks expert in the box to help drive, lower that mean times of resolution to understand why, your particular job had failed. We can expand this out from a pipeline perspective. And so what you're seeing right now is a very similar view that you were seeing previously, but this is now talking about like, a number of job runs over time. And so this graph here shows a time series view of, here are my job runs, right? And here's the duration, for each of these job runs. So this is a simple Spark job that was spun, but, this could also be like a complex multi-stage, run as well. And we can capture all that and track that. We can look at things in terms of duration. We can look at things in terms of IO. And so, if IO is increasing over time, I can see that. We can even track this over cost, right? Like how much is this costing me over time, right? So, if this truly is increasing over time, and hey, that's actually the business requirement. Maybe it's a customer's data is always growing. You're going to want to know that so the way you can forecast this more accurately. But yes, you can see this from a cost perspective. I'll go back to duration. And so by default, what Unravel will do is it will default to this particular time. But if I wanted to say, for example, hey, this is an anomaly, I want to understand what happened here, I can go ahead and click on that Spark or that run. And now I'm on this run and I can see things such as like, hey, how did this compare versus my last run, right? What's the difference here in terms of like, the average time? It usually takes 5 minutes. This one took 6 minutes and 43, which is 29% longer than what it usually takes. And so that's, those are some useful inputs. And then just like how we were seeing with the particular Spark job, I can actually go ahead, click in on this particular Spark instance, look from an observability standpoint, where did my time take? I can use the recommendations engine here to get some more interesting recommendations in this particular case, like a cost-effective instance recommendation, and then consented driver. So it looks like, hey, in this particular instance, it looks like the driver was taking up most of the time. It wasn't actually submitting, the jobs, to the executors, right? And so, various insights for you to effectively come to mean time to resolution a lot quicker, for scheduled jobs, data pipeline jobs. So think of things like Data Factory if you're in Azure, or maybe you're using Airflow, or maybe you're using, Control M, whatever it may be. You've got these scheduled jobs, you want to track it over time. Unravel gives you that great observability of understanding where trends are happening over time for your Databricks environment. All right. Last but not least, ensuring return on investment by understanding usage trends, and we do that here. And so we've got some great reports to think of it as like giving you another dimension of what you probably are getting from within the out-of-the-box tools today, but a little bit more granular, right? So if I want to understand, right now I have workspace selected. I want to understand, in this particular case, the number of job clusters that get spun up. I can see those trends. I can also see this from a workspace perspective. So if I have multiple workspaces and I want to understand, how that's trending over time, I can see that. I can do this from a user perspective as well. And so if I want to understand, how much my users are spending number of jobs, I can see that. I can even see this from a cost perspective, like, hey, are my costs increasing over time, right? And who's the one that's submitting most of the jobs over time? And I can get that information from here as well. Again, just understanding usage trends, right? We can do this, very similar story from a DBU perspective. So if DBU is your language, we can go ahead and talk in that language as well. We also have another view. It's this chargeback view. And so we can do this either in an interactive environment or a job cluster environment. And so here's going to be more of a job cluster specific, but same concepts, right? Over a period of time that you can specify, like, how much spend or how much job clusters were, spun up by user, by, how much DBU consumption by user, cost by user, or maybe workspace, or maybe even both. However you want to slice and dice it, we have the ability to show that to the users. And then, really just get a good understanding of like, where did most of my spend go? So it looks like in this particular example, Gopala here is taking up 51% of my DBU spend over the last 6 months here. And, I can go in and if I scroll down here and I can actually select Gopala here down below, and I can actually drill in and say, like, what is Gopala doing here? Like, what type of jobs is he spinning? How much are each of these jobs? How much are they costing me? And so I can get down to that level of detail to further understand, like, hey, okay, maybe Gopala should be spending this because he's doing the most jobs, or maybe, hey, maybe there is room for improvement on some of these, some of Gopala's jobs. Maybe he is over allocating his, his instance types and use Unravel to pick the correct instance type. Whatever it may be, it's always good to, overall understand how usage consumption is, either from a jobs perspective, a pipeline perspective, a user perspective, workspace perspective, whatever it may be. But being able to understand that gives you better visibility to see where things are going, gives you better forecasting, et cetera, and so forth. And then also get in front of maybe some problematic jobs. So that way you really are tuning your Databricks environment for resource efficiency. And ultimately making sure that you're getting the most out of your Databricks environments. All right, so that was that was a demo. Feel free to ask any questions in the chat box. In this talk, we talked about 4 things. We talked about how you can ensure your jobs are adequately resourced. We talked about making sure your code quality is optimal and efficient, and that we're firing on all cylinders from a code perspective. We talked about reducing mean time to resolution. So stuff fails, jobs fail, pipelines fail, things run slower than expected. How do I figure out what was the cause of that, and what can I do next time to address this? And then finally, just overall visibility of how usage is actually being consumed is really going to help you, guide you in the right direction to make sure that you are getting the most out of your Databricks spend. If you're interested, we do have a SaaS offering where you can actually try us. You could even try us today if you wanted to. So all you need to do is go to unraveldata.com/SaaS-free-trial, and you can actually start testing out Unravel, with your own data in your own environment. So, you don't have to take my word for it. You could actually see it in your environment itself. And so we do have this offering as well for folks that would like to start using us today.
Hey, Chris, we do have a few questions before we
Sure.
go. Let's see. Let's put us back. All right. So the first one, do you work across all Databricks cloud vendors?
That's a great question. So we work with Azure, Microsoft Azure. We work with Amazon, AWS. Google is something that we're working on. But as everybody, well, I wouldn't say everybody knows on this call, but like that's a newer offering. So we are getting up to speed on that, but we will be supporting Google on Databricks, or Databricks on Google shortly.
Perfect. Okay. How do you install Unravel in my Databricks cluster?
Sure, great. That's another great question. So, we've got that SaaS offering that I had mentioned previously. So, you can if you want to have like a really quick evaluation. It's 14 days free trial of using Unravel. We've got a nice guide to kind of help guide you with some of the questions. And so this would be a nice route for folks that want to try Unravel, but maybe they don't want to necessarily talk to a sales team just yet. They just want to have like, self-guided tour, and they have this option. The other option that we have is we've got marketplace offerings in both AWS and Azure today. And so if you want to go ahead and install Unravel, it's as simple as just clicking our marketplace offering and then just doing a few configuration, and then you're off to the races, evaluating Unravel in your own environment.
Thank you. Okay, we've got one more. What kind of data do you collect from my Databricks instances?
That's a great question as well. So for folks, this comes up a lot with folks that are really, security conscious. The good news is we're not actually monitoring your data per se. So we're not going into seeing any like PII data. We're not doing anything of that. The only thing that we are collecting are just metrics, diagnostics. I hate to say the boring stuff, but stuff that's going to be very, help you understand things from a performance perspective, so we can help guide you in the right direction. But yes, we don't actually see the actual data itself, but we are collecting various metrics, diagnostics on job performance.
Thank you. Okay. If there are no other questions, then we will close out on this webinar. This webinar is available instantly on demand. Again, feel free to share with your colleagues or peers via the same web address. And if you are watching on demand and would like to ask a question, please email us at hello@unraveldata.com. Let us know what you think about the session, rate this webinar, let us know if there are other topics that you would like to hear about. And I'd like to thank Chris very much for sharing his expertise today.
No problem.
And for your time today. And we definitely hope to see you at a future live webinar. Thanks so much.
Thanks, folks. Thanks, Diana. Bye for now.